Good morning, everyone. This is Soumyaranjan Nahak. Welcome to my channel Renu Ratna Patsala. So I am here with new topic, that is minimization of DFA. We had already studied about the construction of DFA, how to construct the transition table from the DFA. So in today's class, we will learn how to minimize a DFA. So my topic will be minimization of DFA. Minimization of DFA means in this procedure we eliminate or we remove some state. How? We will learn now. So before going to the example, I will give some brief introduction of it. Minimization of DFA means converting DFA to its equivalent DFA with minimum state. It convert the DFA into a DFA which have minimum state. Suppose in first DFA we have 7 states. When we minimize it in to the 5 state, then the working or the functionality of the DFA will never change. So that we minimize the DFA, because when we minimize the DFA, the transition table will minimum. When the transition table calculation will minimum, then it will be easy or concise or precise to learn us. So converting the DFA to its equivalent DFA with minimum state, that is known as minimization of DFA, and it also known as optimization of DFA. Optimization of DFA. We had already learned about the construction of transition table. We will implement the construction of transition table as well as how to eliminate the states from DFA, and how the minimization of DFA and the original DFA result will be same. We will learn now. So let me erase. So there is a procedure, or we can call it theorem, or there have some steps to minimize the DFA. Before going to the DFA, we will learn types of minimization of DFA. In two way we minimize the DFA. First is normal method or equivalence method. Second one is Myhill narrowed theorem or table filling theorem. Minimization of DFA can be done by two procedures. One is equivalence method or normal method. Second one is Myhill narrowed theorem or table filling method. So we will do the example of minimization of DFA by using equivalence method. So According to the equivalence method, there are several steps to complete the procedure of minimization of DFA. So first step 1 is eliminate the inaccessible state to initial state. Eliminate the inaccessible state. We will eliminate the state which is inaccessible to initial state. Suppose we have a 10 states. Two states is not connecting directly to the initial state, then in this case we will eliminate to these two states. So first step is eliminate the inaccessible state. Step 2 is after eliminating the inaccessible state, we will construct or draw a transition table. Transition table. So write down or take a screenshot. So let me erase to write the third step. Step number 3 is divide every state into two groups. In first group contain all final state. Second group contain remain states. So step number 3 describe we have to divide all state into two groups. One contain all the final state and second group contain all the remaining state besides final states. So step number 3. In case of step number 4, we will use the counter partition or the counter variable. Counter variable is k. So write down, because my whiteboard is so small, it is very clumsy to write everything in one time. So take a screenshot or write down. I will erase. Then after I will write down. I will write the next steps. So next step will be, if we are doing a partition or we are doing a group of each state, every state, then the partition will represent as P or pi, because some books it has written pi, some books it has written P. So we are doing the partition and the partition is representing by a symbol that is P or pi. Next last step is we will do the partition till to get pk equal to pk minus 1. When we are getting this kind of equation from the questions or solutions, then we will stop here, and here the minimization of DFA is completing properly. So let me explain the example of it. So this is the example of DFA, and we will try to minimize it by using equivalence theorem. So I had already explained you about the steps. There are different types of steps. So we will try to implement these steps in it upon it. So first step, step number one, define, eliminate the state which is inaccessible to initial state. So here initial state is Q0. So we will check which state is inaccessible to initial state. So Q0 have a direct connection A, it is not inaccessible. Q0 have a arrow mark to Q1 means it have a connectivity. Then from the Q1 to Q2 have a connectivity that is A. From the Q1 to Q2 that have a Q2 to Q1 that have a connectivity A. Here one inaccessible state is Q3. Why? Because Q0 have a connectivity with Q1. There is a transition A. We don't have a transition or path from Q0 to Q3. So it is inaccessible because when we are talking about the Q1, it have a connectivity or transition. Directly or indirectly connectivity is required. In case of Q2, it has a connectivity to Q1 that is A. But Q3 is inaccessible, so we will eliminate Q3. Simply we will write according to the step 1, we will eliminate Q0, Q1, Q2. We will do the remain transition as same as before. We are getting this kind of DFA after the solution of or after the completing of step 1. Then we will go to the step 2. In case of step 2, we will do the transition table of DFA after elimination of inaccessible state. So we had already learned about how to draw or construct a transition table from DFA. We must need different kind of column. In first column we are situating states. In several columns we are situating number of inputs. So here we will implement state. How many inputs are here? How many symbols are here? That is A and B. So for two symbol we are creating two columns, that is input for A, input for B. So simply we will write the initial state, that is Q0. If we will put A in Q0 state, to where it is going. If we will put A in Q0, it is arrived at Q1. So if we will use B as an input in Q0, it is arrived at Q2 itself. Sorry, Q0 itself. So Q1, Q2, Q1, Q2, Q1. It's like these two states, we will fulfill the Q2 state also. Sometime this is the sometime final state is denoted by asterisk symbol or star mark. Sometime you will get a information of asterisk mark is used before the final state, but it is not mandatory. You can write it simply. If we will use A, in Q2, then it is arriving at Q1. If we use B in Q2, it is arrived at Q2 itself. So we have completed the step 1. We eliminate the inaccessible state. In step 2, we draw the transition table. Next step 3, we are constructing or partitioning the each state, and each state divided into two groups. In first group, we store all the final states. In second group, we will store all the remaining states. So let me erase. In step number 3, we are partitioning two groups, and a partition can be represented by using P or phi. So we are taking P0. First group is Q0, and each group quoted with curly bracket, open curly bracket and close curly bracket. So there are two final state, that is Q1, Q2. Each state should have to grouped in, or should have to situate in one group. So we got two groups. In first group, we are getting the non-final state, and in second group, we are getting the collection of final state. So now we will check the equivalency. Equivalency means, before going to check the equivalency, we must have to do the transition table, because transition table is most required. So let me do the transition table. State A, B, Q0, Q1, Q2. So we will check the equivalency by following the rule and regulation of transition table. So Q0, there is no equivalency because it is a single entity, that is Q0. Here we will check does it maintain the equivalency in between these two states or not. How we know it maintain the equivalency? So let me check. So if Q1 and Q2, so we will directly go to the Q1 and Q2. So in first case, if we will put A in Q1, we are getting Q2, and if we put A in Q2, we are getting Q1. These two states belongs to one group or not. If it does not belong to the one group, then it is not maintaining the equivalency. If it belongs to one group, then it is maintain the equivalency. So Q2 and Q1 both are belongs to one group, it maintain the equivalency. So next phase is, we had already verified with input A. Now we will verify with input B. If we will put B in Q1, then we are getting Q1. If we will put B as an input in Q2, then we arrived at Q2 state. So Q1 and Q2 both are in one group. So here we will simply draw the DFA machine or minimization of DFA machine. Q0 will be one group, Q1, Q2 will be one group. Why? Because it maintains the equivalency and both are final state. For the final state, we are marking with double circle. So here we will check, if we will use A as an input in Q0, then we are arriving at Q1. Q0 implementation of A, we are getting a state of Q1. Q1 is arriving here. So next step, if we are using B as an input in Q0 state, then we are arriving at Q0 itself. So we will simply write B. Then we will go to the Q1. If we will use A in Q1 step, then we will arriving at Q2. If we will use B in Q1 state, then we are arriving at Q1. So here two symbols are used, that is A and B, or we can use it in this state. So as like Q0 and Q1, we will follow the same procedure in case of Q2. So if we will take A as a input in Q2, it is arriving at Q1. So if we will put A as a input in Q2, it is arriving at 1. It has already existed. So we will never do the repeat thing or the same thing again because it is already existing here. So for B, if we will take B as a input in Q2, then we are getting a state of Q2. So if we will use B in Q2, then it is arriving at Q2. So it has already existed. So we don't need to implement the B again. A as a input in Q2, it is arriving at 1. It has already existed. So we will never do the repeat thing or the same thing again because it is already existing here. So for B, if we will take B as a input in Q2, then we are getting a state of Q2. So if we will use B in Q2, then it is arriving at Q2. So it has already existed. So we don't need to implement the B again. Here we are getting the minimized DFA and the original DFA. One more important thing you must have to know whenever you are doing the question of minimization of DFA. The value or the result of original DFA will always be same as the value or result of minimized DFA. If the value will be changed, then it is not a proper procedure to minimize the DFA. So thank you for watching. We will meet in next class with rest of the part. Do like, share, comment and subscribe. Have a great day.